Hi everyone, so welcome to today's lesson. I'm going to be showing you how to solve the questions that I gave you in the previous exercise on formation of differential equations. So let us quickly begin. These are the questions. This is the exercise that I gave you. Formation of differential equations and identification of the degree and the order of any given differential equation. So the first question is, write the order and degree of the following equations. So the first equation is this one. This is the first equation. So just by looking you can tell to say the order of this this is simply 2. Sorry for that. So the order of this is 2, and then the degree is simply just the power of the highest order, which is just 1. So this is how, sorry for that. So this is how you simply solve such an equation. Let's quickly move on to the next question. So I said the order is 2 and then the degree is 1. Okay, so we'll move on to this equation. So the next equation is so here the order was 2 and then the degree was 1. So here before you even start solving, you first need to get rid of this square root. We know to say this 3 over 2 can also be written as 3, then 1 over 2, something like this. So this is the power we have there. So if you have such a power, what you need to do is you simply, so if you have such a power, you simply have to first have to get rid of the square root. Let's get rid of the square root. So when we square root when we multiply this side, or sorry, when we raise this side to the power 2, even this other side to the power 2, we're going to remain with something like this, 1 plus, then we have dy dx, and then we have this being raised to the power 2. Then this side, the power there will just remain 3, because 3 over 2 times 2 you get 3. Then this side you are going to have everything in the brackets here raised to power 2. Then here we are going to have d2y dx2. Okay, so now if you look at this equation, now we've gotten rid of the square root. So we're going to have, so here when you look at this equation, you can now agree with me that the order is 2, and then the degree is also 2. So here the order will be 2 and the degree will also be 2. So if you want to know why I've gotten rid of the square root, you can go back to the definition of the degree. So degree, you take the power of the highest order of the differential coefficient, and then you make sure that before taking that you get rid of all the fractions and all the square roots. You can revisit the definition, you'll see what I'm talking about. So on this last equation here, this one is straightforward. The order is 2 because that's the highest d2y dx, that's the highest dy dx we have there. It's 2, and then the degree there is simply just 3. So we can now move on to the next question. So the next question says, obtain the differential equation of which y squared is equal to 4ax plus a is a solution. So this is a solution of some differential equation. So we need to get that differential equation. So how do we do that? First of all, you differentiate. So when you differentiate y squared using implicit differentiation, you get 2 y dy dx, and then in this side, when you differentiate all this, you simply just get 4a, because when you differentiate 4ax, you get 4a. When you differentiate 4a squared, because when you multiply this and that, you get 4a squared. So when you differentiate 4a squared, you simply just get a 0. So when you differentiate 4ax, you get 4a. So after getting this, you can now make a the subject of the formula. So this is a. So a is equal to, in this equation, we're going to have, when you make a the subject of the formula, you're going to have 1 over 2y dy dx. So having done this, you can now replace this whole expression in this. Where there is a, you put that. So we're going to, let me just simplify this. This can also be written as y squared is equal to 4ax plus 4a squared. So when you differentiate this, you are getting that, and then when you make a the subject of the formula, you are getting that, and then after that, you now take this whole expression of a, you replace it there. So you're going to have something like this: y squared is equal to, where there is a, we put half y dy dx. So meaning we say 4a. So we say 4 half y dy. So here what we're doing, we're using that method called eliminating the arbitrary constants. So we're trying to eliminate we're trying to eliminate a. So 4, and then while is a squared, we still put the same thing. So this is y, this is not x. In case you see it to be x, this is y. So this is squared, and then y squared is equal to, so you multiply all this, you're going to have 2, you're going to have 2y dy dx, and then when you multiply it with that x, you're going to of course have 2, let me just write it as 2xy you're going to have 2xy dy dx, and then apart from that, you now have when you multiply this times that, you just simply get plus this half to the power 2 is 1 over 4. 1 over 4 times 4 is 1. 1 times x, you just get x. So 1 times y, you just get y. So you're going to have y squared dy dx also squared. So dy dx will also be squared. So you take this y squared to the other side of the equal sign for you to just leave it in the format of a differential equation. So you're going to have let me say y squared dy dx squared, and then you have plus 2xy dy dx, and then minus y squared is equal to 0. So this is how simple these questions are. This is how you solve such a differential equation. So let's quickly move on to the next question. We see how to solve it. So this is the solution, we have obtained the differential equation for this solution. So let's quickly move on to the next question. So the next question is find the differential equation corresponding to that. The question is just the same as what we're just from doing, so I'll just solve it quickly. Yeah, so first and foremost, the first thing that we need to do is we differentiate that. So when you differentiate this, when you differentiate y by implicit differentiation, we get dy dx, and then this is going to give you, when you differentiate this, you simply get 3a e raised to power 3x. So when you're differentiating e, you simply differentiate its power, then multiply it with everything, then plus differentiating this, since b is an arbitrary constant, will just give us the same thing, b e raised to power x. So in this equation, what we do is we make one of these two constants the formula, the subject of the formula. So myself, I'm going to make this as the subject of the formula, meaning I'll take this to the other side of the equal sign. So I'm going to have something like this, dy dx is equal to, to be minus 3a e raised to power 3x, and then you're going to have this being equal to b e raised to power x. Then what you do now, after making this as a subject, you simply replace it in this main equation. So you replace it in the main equation. Then after the replacements are done, you're going to have something like, you write your y there, so y is equal to a e raised to power 3x, then we put this where there is b e to the power x, we're going to put that. So we're going to say plus dy dx, then minus 3a e to the power 3x. So apart from this, after doing this, you just simply now you just simplify. So this minus that, you get something like, this is negative 2. So when we simplify that, we're going to have dy dx, then negative 2 a e raised to power 3x. So and then apart from that, what will follow now is that you have to differentiate this again. So when you differentiate this, you are going to have, when you differentiate y, you get dy dx, and then this is going to be equal to, when you differentiate dy dx, you get the second derivative. So you get the second derivative, which is the 2y dx2. And then when you differentiate this, you get negative 6a, e raised to power 3x. So after doing this, you now make this arbitrary constant the subject of the formula. You can either make a the subject of the formula, or everything, or all this you make it as a subject of the formula, since it's in the since you are able to see it in the main equation. So we now replace it, we make it as a subject, and then after that we replace it into into this equation here. to this one. So let's quickly make it as a subject. So we're going to have something like this: a e raised to power 3x is equal to 1 over 6, open brackets. When you make it as a subject, 1 over 6, so let me say negative 1 over 6, or if you want, you can just, when you take this to the other side of the cosine, it's going to be dy dx minus dy2, I mean the 2y dx2, and then when you divide by negative throughout, you get the what's this, you just switch them. The one which was negative will be positive, meaning instead of having the 2y dx2 to be negative, it's going to be like this: the 2y dx2 will be positive, and then the one which is going to be negative is dy dx, and then you put this in brackets. So we now replace it in this equation, we put it there. So we're going to have our y being equal to dy dx minus 2, and then while there is this ae to the power 3x, we replace with this equation. So this is just going to be 2 over 6, and then open brackets, the 2y dx2 minus dy dx, like that. So when you simplify this part here, you just have this, you're going to have 1 over 3. Then for you to get rid of this 1 over 3, you can multiply throughout by 3. So you're going to have 3y this side, and then this is going to be equal to 3 dy dx. Then this negative times, and then this will do us is 3 times this, 3 times 1 over 3 just give us 1. Negative 1 times the 2y dx2, you get the 2y dx2. Negative 1 times that negative dy dx, you get positive dy dx. So after this, you now just simplify it by putting the like terms together. So when you add dy dx, 3 dy dx plus dy dx there, you get 4 dy dx, and then we have that negative the 2y dx2, and then minus this 3y. This will be equal to 0. So this is our differential equation that was needed for us to find. This is our differential equation that was needed to be found. So if you look at this, if you want, you can do what? You can divide through by negative and get something like we make the 2y dx to be positive, you can have something like this, then minus 4 dy dx, and then plus 3y. It's still going to be the same. There's no difference between the two answers. So this is our final solution. You can either write this or this, you still be marked correct. So thank you very much for watching. I hope you've gotten one or two concepts from what I've taught, and the next time we meet, I think we'll have to discuss we'll have to go in details about differential equations. So if you have any questions in this in what I've sent so far, you are free to contact me using my WhatsApp line, which is 0960 10 80 64. So my name is Hamted. You are free to contact me on that line. So see you in the next lesson.